is titled All the Buttons, Abusing Features Old, New, and Unreleased. So a little bit about me. I'm 22, I'm from Melbourne, and nowadays I'm nowhere. I do a little bit of security research as mentioned, but I work on just open source projects, a lot on Nix packages lately, and those are my social media. But the project that I'm talking about today is coming from my experience last year when I went to Athens and participated in the International Cybersecurity Challenge. We had 115 people from 7 teams around the world come together and compete over 2 days in this cybersecurity game. And it was just super fun. One of the games was attack defense. So in attack defense, we have this hypothetical situation. Let's say that you're an ops engineer and you have a product and you've just been told that, hey, suddenly we have all of these attackers coming at it and, well, you don't know what's wrong. You just know that there are people actively trying to exploit your app. Now, what your job is to try and figure out what's going on, how they're getting in, and try and patch up your code that you've been given that's got a few vulnerabilities in it to try and make it safe again. The twist being, also at the same time, your teammates are working on the other side of the fence. They are the attackers. They are trying to break into every other team's app. Everyone has identical apps that they've hosted up, and so for every vulnerability you find, every point you score, every team you hack, you get points, and you lose points when you get hacked. Also, most importantly, you must remain up. You can't let your app go down for even a second, or you're deeply, deeply penalized on the scoreboard. So, yeah, all fun and games. I'm sure it's never happened to anybody in real life. So yeah, this is the scoreboard app from last year, and you can see how all the different teams were tracking at this moment. So this goes for a couple hours. It's really quite a high-pressure situation, and it was just a lot of fun. So when I went home, I decided that I wanted to kind of recreate this, to replicate this game, and because I love Tailscale, I want to do it all with Tailscale, and at the same time, make it the best, most intuitive, user-friendly experience that you can have. So this is not a very simple system. So this is sort of how the network was set up on the day. So you can see there's multiple different subnets. Every single player gets given a username and password for the scoreboard. They get given a WireGuard key to go into the network, and they're also given an API key so that they can write scripts to talk to the scoreboard. This is all information that has to be emailed to the players beforehand, that you have to test that it works. Each of the virtual machines that have a vulnerable application, they're set up so that only the teams themselves can access it until the game starts, in which it's a complete free-for-all. And just to make sure that the games plays fair, you have this router in the middle that makes it so that any data that gets up to the virtual machines is completely anonymized. It hides all of the IP addresses using a source NAT so that you can't just easily say, hey, I can see all of my attackers are coming from this place and that place. So this is kind of the network that we are trying to replicate. Do it better. So now I'm going to go into a bunch of demos, so wish me luck. So, okay. First off, with Tailscale, we don't have to make usernames and passwords for everybody. We don't have to give them a password to a VM or take their SSH keys. We can just invite them to a tailnet. In this case, it could be through a GitHub organization that I've made. And once users are on the tailnet, we can put them into groups and use access control lists to control who can talk to who. You can make it so that if you're on the same team, you can connect directly to each other, share files, have complete freedom, but tightly control what other devices that you can talk to. And this is all completely invisible to the end user. As an end user, if I just say I want to SSH as root into my team's box, let's say I'm on Team Oceania, I can just do SSH into Oceania. And fingers crossed. There you go. We're into our team's unique virtual machine. And this is completely automatic. I didn't need to be given any passwords or keys or anything. It's all no muss, no fuss. You just download Tailscale and log in. And it works perfectly first try, which is like amazing for a user experience. Especially if you've have to muck around with WireGuard and Linux networking and all that. Tailscale can just wash it all away. Mm-hmm. So the next thing that we can do is that scoreboard that you showed earlier. This is actually my clone of it. And you can see here that I'm running it on a Tailscale address. This is using Tailscale HTTPS certificates. And that up there is actually a funnel address. So what should happen is, I was testing this and I don't think it's working right now, but if you go to this, this would be a public scoreboard. So any observers can keep tabs on the game and see what's happening. But at the same time, through only logging into the tailnet, you don't have to sign in with username, password. You don't even have to sign in with your single sign-on provider. Simply just being on the tailnet lets our scoreboard know who we are. You can see in the bottom right corner, it's got my name and picture right there. And so teams can then just use a scoreboard. They don't have to log in when they write their apps and scripts to interact with this. They don't need API keys. It all just works because the scoreboard is smart enough to see exactly who you are. And as Z mentioned in a talk earlier, this is really novel because for the first time, this is the first time I've ever been able to have a service that is both internal, that I can access through a VPN and do all these privileged actions like have my admin interface, while at the same time serving a copy of that that's just read-only and public that for the whole internet to see. And the coolest part is it's both at the same address. You don't need to say, hey, use this address for when you're on the VPN, but use this if you want to see it publicly. The user just sees, hey, I'll just go to this one website, and I can do everything there. Which is, yeah, I'm a real big fan that Tailscale lets you do that. Now, when I was implementing this a few months ago, it wasn't completely bump-free. So funnel is sort of a new thing, and Tailscale off, which I'm using here to try and figure out who's who, is a little bit of a niche feature. So when I was combining the two, I actually ran into a little bit of technical problems, especially because this is not a Go app, this is a Dino app. And so I'm actually not able to use TSNet here. So I actually had to go into the Tailscale client and sort of do a little cheeky hack to get this to work. But hopefully that is all smoothed out now. But it did show me that, say, it's surprisingly easy and approachable if Tailscale needs to do a little bit more than you want to dive into the open source code on GitHub and just play around with it. I'm not a Go engineer. I wouldn't say that I know any Go, but I managed to do enough to get it to work for me, and that's fantastic. Can't say that about every product, but yeah, that's a really great thing that I really appreciate being able to do. And then one last thing that I want to highlight with this network that we want to replicate, a very important feature of it that makes the game work is this router that can do that IP anonymization. It can actually hide all of where the traffic's coming from. And now how do we bring that into the world of Tailscale? The concept of anonymous tailnets, nodes that can talk to each other and send traffic, but without knowing who each other are. This is kind of a contradiction. Tailscale is a peer-to-peer network. It's for humans making connections. So we're reaching a little bit outside of the bounds of where you'd normally go here, but it does work if you interpret the rules with a little generously. So there is one feature that Tailscale has built in that allows you to aggregate traffic, that lets you, take requests from a whole bunch of different users and push them through one place. That's the subnet router. And in fact, the subnet router lets you have a device on another network that's not on Tailscale, and that you can then expose to your tailnet and have all of your data, all of your traffic when you go to the route through Tailscale automatically. And while it's doing this, it's also acting as a NAT. It's rewriting all of the traffic so it comes from the router's IP address, and it's just sending it through. This is just things that a normal subnet router is doing automatically for you that you may or may not have known. And so if we get a little bit generous, what if we don't make just any old subnet? Tailscale has millions of IP addresses. They're all randomly generated and assigned. And so what if we could make a subnet over every single one of those millions of IP addresses? Then, if this subnet router advertised every single Tailscale IP, and you went to that new IP address, it would route all your Tailscale traffic through it, and it would be completely anonymous. And so what I actually did was, I can show you in this dashboard, You can see here I have a subnet router that I'm advertising this big whopping subnet on IPv6. And so basically every address in here gets automatically mapped to a Tailscale address, and it gets anonymized. The demo here, I can refresh this. This is just a Hello World service running on TSNet. If I use this IP address and I transform and get the equivalent IPv6, and I refresh it, you can see that even though I'm sending the traffic from my laptop, it gets automatically, completely, just anonymized. And that's how you make Tailscale networks that don't know who each other are. Ooh, there is one more thing, but I don't know if it will work. Okay, so now we have another user interface problem because we've just given every single device a second IP address. You can see up there, like each virtual machine already has an IP address that if you're connecting into it using Tailscale SSH, that's perfect. But now we've just given a second one that we want to give out. And it's a little bit, I don't quite love it if I have to say, hey, use this IPv4 if you're connecting your own one, but use this completely random IPv6 if you're connected to another team. So instead, what I did was I made the DNS server that lies to you. So here you can see, if I look up Oceania, okay, I'm getting this from our regular, normal Tailscale IP address. But here, I have this machine is on another team. So imagine this is a second team's machine, and so the other team's on this. But if I try and connect into the Team Oceania server now, oh no. This should, sorry for the demo, but this should give that IPv6 address instead. And how this is happening is I have a TSNet DNS server. This is something that you can do if you've been keeping careful attention on the Tailscale source code, but you can now run UDP services over TSNet. So I've written a TSNet DNS server that when a client asks it, hey, what's the IP address of this hostname? It actually checks which client is making the request, whether you're on that team or not, and if you are, it gives you the real one, and if it's not, it gives you the masked one. So as a user, this whole subnet is completely invisible. This whole subnet router is completely invisible to you. You can just use the one source of truth hostname to do all of your actions, and yeah, I think that's like really great. And yeah, thank you.